Okay, question 1 for the MP1 paper N, series of papers created by Madas. We're asked to show that x minus 5 is not a factor of f of x. So if x minus 5 is not a factor, then that means that if I set this bracket equal to 0 and solve for x, which will give x equals 5, that means if I find the value of f of 5, so I substitute 5 into the f of x function, then this should not equal to 0. If it were a factor, then when I substitute 5 in, it should equal exactly 0. So when I substitute 5 in, 5 cubed is 125, minus 3 lots of 5 squared, so 3 lots of 25 is 75, plus 6 lots of 5 is 30, minus 40. Well, 125 minus 75 is 50, plus 30 is 80, minus 40 is 40. This is clearly not equal to 0, so x minus 5 is not a factor of f of x in this case. Find a linear factor of f of x. Okay, the trick to this is I know the coefficient of x cubed is 1 and the constant term is minus 40. So if you multiply 1 and minus 40 together, I've got to think of factors that multiply to negative 40. Okay, now there's a mixture here. We've got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and so on, 8, 10, 20, and 40. There's quite a few to go through. So let's try the easy ones. So let's start with plus or minus 1. So if I was to substitute in positive 1, this will give... Well, let's just do the negatives first, and I'll show you why. Because if I subbed in negative 1, minus 1 cubed is minus 1. Minus 3 lots of minus 1 squared is minus 3 lots of 1, which is minus 3. Plus 6 lots of minus 1, which is minus 6, minus 40. Okay, this is 4 negative numbers. I don't need to compute this. I know this is not going to be 0. And if I try positive 1, let's think very carefully. This term will change sign, so that will become a plus, and this term will change sign because that will be a plus. Positive 1 squared is the same as negative 1 squared, so it's going to be made negative anyway, and minus 40 stays the same. So in this way, I can compute these things fairly quickly, knowing that if I take the negatives first and then change those two terms to a positive, then I can race through these fairly quickly. So minus 43 plus 7, if I combine all the negative terms and the positive terms, is still going to be negative clearly, so it's not plus or minus 1. Let's try negative 2. So I've got minus 2 cubed, which is 8, minus 3 lots of 2 squared, which I believe is minus 12, because it's 4 times minus 3. 6 lots of negative 2 is minus 12, and then minus 40. So that's not going to work. Let's try positive 2, so then this one gets made positive and the third term gets made positive. These two terms will cancel, but plus 8 minus 40 is going to give negative 32, so that's not going to work. Let's try minus 4. So minus 4 cubed is minus 64. Minus 3 lots of 4 squared is going to be negative 48. 6 lots of minus 4 is minus 24, and minus 40, so that's not going to work. Okay, now if I take positive 4, then plus 64 and plus 24, and lo and behold, I think this looks like it's going to work, because 64 plus 24 will give positive 88, and negative 48 and negative 40 is negative 88, so this indeed equals 0. So that means positive 4, so f of 4 equals 0, that must mean x minus 4 is a factor. So really that's what the question really wanted me to show, and I could go one step further and factorize this, because this has to be an x squared term. I know the number terms have to multiply to minus 40, so the last term has to be positive 10, and then if I think about the coefficients of the x squared terms, I've got minus 4 times x squared, which is minus 4x, but f of x is minus 3x squared, so this has to be plus a single x, so that x times by this x gives a positive 1x. And I can confirm this by multiplying out further. by doing minus 4 times x, which is minus 4x, and then x times 10 to get plus 10x, and 10x minus 4x gives me the plus 6x, and then it works out in the end. So there you go. X minus 4 is the linear factor we're looking for.